Okay. Let's cover 9-2. Here we go. I need some other markers, don't I? Oh, no, I don't. What a dumb person I was. What are you crying about?
Nothing.
Well, I don't know why not with that face. See, I have to show you how to actually do a roast. My young Padawan.
I was talking about how Tom Holland is not attractive to you.
Oh. Yeah, he's a dumb-looking little kid.
Okay, you can go to like any grocery store and find someone who looks like Tom Holland.
Yeah. People are not attracted to Tom Holland because of his face. It's because of his voice. His squeaky little British voice.
Yep. Squeaky little British boy.
But
I mean, British voices are attractive, just not.
okay, well there's like 60 million of them.
That's true.
Go over there.
There's significantly more attractive British people.
Yeah.
Of course, you could go for French and be attracted to what's his face?
Timothy
Oh, Timothy
Chalamet.
Chalamet?
Yeah, that one.
Like he ate a 52-inch TV.
Well,
That was a stupid statement. That is a petty Gen Z roast that is a whole lot of nothing. That is the kind of crappy quote unquote roast that Gen Z does all over the internet. Oh my gosh, have you seen their face? They messed up their mascara. Oh my gosh, shut up and quit being insecure. Quit blasting your insecurities to the whole world. Stupid Gen Z quote unquote roast. Go meet a Gen X person. Try again.
I didn't say anything.
Try again. Go cry to your mother about all your insecurities.
I will.
Have fun in therapy.
I will. Except my therapist like gave up on it. Yeah, that makes sense. Wait for it.
Okay.
That's beyond. No.
Translations. What does this word mean?
Take a word in one language and put it in a different one.
Wow, that's true. That is one definition of that word. Take it in, and from one word, one language, and translate it into another, or possibly move it to another. Because in math, that's what it means. So let's do an example. We're going to cover 2 lessons today, and we're probably still going to get out early. Probably. Maybe not, but probably. Have I mentioned that I hate this unit?
I think somewhere probably.
Okay. That's not why we're going to get out early. We're going to get out early because it's easy. Okay, we're going to translate. Let's make up a shape. Pick a letter. EQY. That's a weird name, weirdly named triangle, but we'll go with it. E is at 3, 3. And Q is going to be at -2, 1. And Y is going to be at 1, -2. And our instructions say something to the tune of translate this along the vector. This is the only thing that makes this high school. Because in middle school, we would have been like, translate this 3 units up and 2 units to the left. But in high school, we knock over trash cans. And then, after that, the instructions would say, translate triangle EQY along the vector negative 3, 1. So, what do you think you're going to do in order to do that?
Draw the vector.
You can draw the vector from each point. So negative 3, 1, negative 1, 2, 3, up 1 from this vector would be right here. Probably should use a ruler if we're going to do that.
I'm confused. Are we not instead of just moving it 3 in there?
We are, yeah.
So what's the difference? We use
The wording. That's it. That's what I'm saying. Yeah. We're moving this back 3 and up 1. That's exactly what we're doing. Yeah, it's just high school language. That's kind of was the point I was making. Yes. Back 3 up 1. So right here. And then back 1, 2, 3 up 1. So what are the coordinates of triangle? Well, actually, let's not do it that way. What are the coordinates of E prime?
0. Wait, E prime, yeah, 0, 4.
Oh, it would be if I drew it right. Yeah. Now, how would we get there algebraically if we so choose? So we would take the 3, and do 3 minus 3, and 3 plus 1, which would give us this, right? What about Q prime? Negative 5, 2, which we would get by taking it algebraically or arithmetically, I don't know, not with a picture, by doing negative 2 minus 3 and 1 plus 1, right? What about Y prime? Yeah, which we would get the same way. By doing the 1 and then minus 3 and the negative 2 plus 1 would give us this. And then we connect the dots and you got the original and you've got its, whatever it's called, translated one. You draw it, right? And there it is.
So if you define it algebraically, is it always negative?
It's always whichever way the vector goes. So this one goes with the x coordinate and that one goes with the y coordinate, right?
Or like plus and minus. Like, is it minus because it's negative 3?
Yep. That's exactly right. Any other questions about this example?
What is, so on the Y, what is that symbol you put in here? Is that supposed to be
It's an arrow. It's just a squatty arrow because there wasn't much room
which way?
from this to this.
Okay.
Let's do one more example in this lesson, probably. If I can find one like what I'm looking for. Yeah, I think that's what we're going to do. Okay, we're going to do guided practice 3 on page 634. Need my eraser. It's right there, where I figured it would be. Isn't that grand? What do y'all think? You think the fire will work today? Any bets? I'd probably give it like 20 to 1 odds. The question was 3 on 6 whatever. And the other question was, do we think the fire is going to work? Wow, you could have earned some money right there because it totally worked. Wow, that's terrifying. Did you say why fire? Why not fire? Sort of. A red flower. Okay. We're mostly doing this example because wording. Because I know y'all aren't real good in vocabulary because you're homeschooled. Oh. See, the thing about that sentence is it doesn't even make any sense. Because like homeschoolers are just like any other people. There's some homeschoolers that are great at vocabulary and some that are awful and a bunch that are in between. Anyway, a coin is filmed using stop motion animation so that it appears to move. Look at the little picture they gave us. Describe the translation from A to B in coordinate notation and in words. So let's do part A. So from A to B, do my best to kind of give a semblance of a drawing. And coordinate notation, and then we're going to do it in vector notation in the next one. Yes, we have to use words. I know, words are hard. So, A, 1, 2, 3, 2, 3, and then, bless you. Oh, never mind. I don't know what that is, but I don't want to touch it. I thought it was just an empty cup with straws in it, but it's sticky and gross. I was just going to use it as a little circle, but we're just going to have to YOLO our circle. It'll be fine. And this looks like down 1 to me. So, A. Great. Looks just like that. B. A big quarter? Oh, yeah. Yeah, it is. But there's, yeah, I don't know. Who the heck knows? Yeah. It's blown up. Okay. And deformed. But don't worry about the deformity. That has nothing to do with the problem. Okay. So we're supposed to describe the translation from A to B in coordinate notation. So, what did we do in the left and right direction? 3 to the right. What did we do in the y direction? Okay, so that is the first part of part A. That's what it means by coordinate notation. Okay, and then the second part is it moved 3 units to the right. It moved to the right and 2 units up. Yeah, that one I did on purpose because the other ones aren't on purpose. The other ones were just like it happened that way. This one was on purpose because may as well keep it that way. So that's part A. Yeah, I am 100% sure that one was on purpose. I'm also 100% sure that one and that one were not. Then part B says, describe the translation from vector A to C using a translation vector. So C is at wherever it is. 1, 2, 3, 4.
7 to the right, 4, no, 3 up.
And then it's up to 2. Yeah. 2. So like right there. See, that dot. Whoa. It dilated. It's okay. Calm down. There it is. So from here to here, 7 to the right and 3 up. So this is the answer to part A. Answer to part B is this. Does that make sense to everyone? Let's do lesson 9.3, rotations, which is more difficult. If only barely. No, I mean, it like actually is more difficult. I could have swore I had a video on rotations. Do I not have a video on the rotations? Let's find out real quick. Where's my cell phone? There it is. Because I could have swore that it existed. I feel like the translation one exists too. And if it does, well, it depends on what you mean and in the context and some other factors like the intention. Their swearing can be bad, but it depends on what you mean and when and where and who else is there and other things like that. What am I doing? No, not that, me.
I completely 100% agree.
You might not agree with all the things I have to say, but
Well, I agree with what I'm hearing so far.
I see. Content. Search. What am I looking for? Translation. Yeah, it's totally right there. Why did I not assign it to you? What happened? Oh, but rotation doesn't exist. Unless I misspelled it. Nope. Well, there you go. Maybe I'm just remembering teaching it in class. So here we go. Continuing on. 9.3, rotations. Rotations is more difficult a concept than translations. Translations is super easy. Super easy, no big dealio. Rotation, in order to rotate an object, you need to know two things. You need to know the center of rotation. And the degree of the rotation. Right? No, it's not the stupidest thing ever. Vocabulary isn't stupid. Vocabulary is useful. I may be interjecting in my voice into the wrong part of your conversation. You may have been talking about something totally different. And translations. Translation is not the stupidest thing ever. But you may have been talking about something else. And it might be, in fact, the stupidest thing ever. I don't know.
Your Honor, I don't recall.
Your Honor, I don't recall. I plead insanity. I plead forgetfulness. I plead ADHD. Anyway, so if I'm going to take and I'm going to rotate this object, then I have to know, in order to describe the rotation or to input the rotation into a program or whatever else, I have to know what I am rotating around and how much I'm rotating, right? So if I was rotating around here, then it's just going to spin around here. But if I'm rotating around this point, then it's going to go like that, right? This particular topic, this one, if you are interested in doing something like video game design, could actually come into play in your life. Okay? We understand that that's not the point of learning math in high school. I've explained it 500 times. However, some things can be useful to some people in their existence, not just in a exercise for your brain, right? I don't know where, no, I do know. Actually, I totally know. Never mind. I'm just going to shut up because I don't have time to soapbox right now. I don't even have a soapbox. Nobody owns soapboxes anymore. What even is a soapbox? It's a wooden crate. Yeah, that's what it is. Okay, so most of our rotations, when we're doing problems, and by most I mean like everything, is going to be, as far as like doing the math, is going to be rotating around the origin. Okay, so, and when you're rotating something around the origin, it has a fancy formula kind of that we can use, especially if the rotations are in fixed locations, which when you're looking at what's going to be on the test, this is what you can expect. Okay. Really tempted to write the radians up here too, but I guess I won't because it's liable to accidentally confuse somebody. Okay. So, if we are rotating an object 90 degrees about the origin, then to figure out the new coordinates of the object, this is where this is different, by the way, from middle school to high school. In middle school, you're rotating something simple like equilateral triangles around its center. That's what you're doing there, or squares or whatever. You're just kind of spinning the shape. Yay, isn't it cute? Right? And you're doing it visually and all that kind of stuff. But in order to rotate an object about the origin, so like if I got this and I want to go 90 degrees that way, right? Then what I do is to get to from the new shape, from the old shape, which would be, or the old point of the shape, to the new point, I flip them around and flip the y. Let's talk about that for a second. So like if I have, it's easier to talk now, you do this with the same way with a triangle that you do with a point, but it's going to be easier to talk about with a point, or even better, I swear I made a video of this. I swear there's a video out there somewhere. I don't know why it doesn't seem to show up on my channel, but you know, whatever. So if I have this point, let's say, draw the little shape, and then we'll rotate it. We'll say that that is at 1, and this is at 2. So this is the point 1, 2, and this one is at 3, 2. In order to rotate that shape 90 degrees, a little line segment, about the origin, it's going to flip over here, right? It's got to, if we tie a string and we're just spinning it around 90 degrees, it's going to take it and it's going to flip it up like this. So it's going to take and it's going to flip the two things, x and y, and it's going to change the sign of the first one. So this one, if I take 1, 2, and I flip them around, it's 2, 1 now, right? But then I flip the y part, so it's -1, 2, which would be right here, right? And then this one, change them around and flip the front one, and it's at negative. That didn't work right at all.
Because you put negative 1, 2 instead of negative 2, 1.
Oh, yeah. Yeah, because you flipped the y part. Thank you. Great. And then negative 2, 3. So it flips it over there to this one with a point shoved in the middle of it because it's cute. My strong, I'm going to show you the other two here in a second. Here, let me fix it so it's not so cute. My strong recommendation on rotations is to memorize these things that I shove up here on this side instead of trying to think it out in your brain. Because if you try to think it out in your brain and try to think about it visually, you're going to mess it up. We've given you little formulas for all the other things we've seen so far. This one, I would just memorize the 3 different things. Get them memorized in your brain and then use them on the test. Because if you try to think about it in your head, you're going to accidentally put it in the wrong place. Make sense to everyone? Okay. So if we rotate a shape around 180 degrees, because this is where it's 180 degree one really where you're really going to screw up if you try to think about it visually because of the way our brain thinks about 180 degrees. If you're translating something 180 degrees, the way you get it is you just flip both sides. Okay? So what it would do to this shape is it would take it and it would flip it all the way down here. Right? And if you're trying to just use your brain to think about flipping something 180, you're going to accidentally flip it some sort of weird version of 90 and like flop it over there. But that would not be that. That would actually be rotating it around over there. Because 180 degrees from this corner is over here, not over here. Does that make sense to everybody? Okay. Well, what? So, where is that orange thing going to appear if I rotate it 270 degrees? Which quadrant is it going to be in? It's going to be all the way around in the 4th quadrant. And it's going to be upside down, which is going to be hard to tell with a line, but it's going to be upside down, right? Because it's spinning around. Okay? So, how do you think you do that translation?
Y negative x.
It's time for a Be Real. Are you real today? Y negative x. Times it. Yeah, we'll do one example and then we'll call it quits. Makes sense to everyone so far, more or less?
So if you do that to all the points of a shape, it's going to rotate the same.
Yes, yes.
And is everything going to be around?
That's right. If you rotate 360, it goes back to the OG spot. That's true. True.
So are we always going to be rotating around the origin?
Yes. Well, on the test you will. Homework, who knows? All bets are off. We have to do a Be Real. That's important. Y'all want to be in a Be Real? I don't care. You're going to be in a Be Real. You didn't give my permission. I don't care. There you are. Don't worry, you're blurry.
Dumb. It's dumb.
I'm just throwing this out there. This is something teenagers should learn, and this is not unique to y'all. That if you're caught in a picture and you don't look good that day, people know who you are, and you look worse when you're like, you look dumb. You look more dumb like that. But you know.
I disagree personally.
Okay, well you're wrong. Own your looks. Because we all know you would walk right into the mall looking just like you look right now. So, you know, what's the difference if it's on a picture? Nothing. Nothing. You would look stupid to the...
I go to the mall.
Man, people that dress at the mall, good Lord. Some of the people, what are we wearing right now? What is even happening? What is even happening with our out? Where is my marker? Oh, right here. Okay, we're going to do guided practice 2 on page 641. Parallelogram FGHI has vertices F, 2, 1, G, bless you, 7, 1, H, 6, -3, and J, 1, -3. As I said H out loud, it reminded me of this little kid. Have y'all ever seen the little kid that's like probably 10, maybe 12? And he like responds to duets to like British people and French people making fun of the way Americans talk, and he like takes the crap out of them. It's like, no, you're wrong because X, Y, Z. It's really hilarious, actually. He doesn't really show his face, but he's like a little kid wandering around in the park, picking up rocks and being dumb, and also like proving them way wrong, and it's pretty hilarious. Anyway, and we are supposed to graph that and its image after a rotation 180 degrees about the origin. So 180 degrees, how do we get to 180 degrees? Great. Let's pretend like it didn't say that, because that's too easy. Just flip both the signs, right? Let's pretend like it said 90 degrees. How about? Okay, so to get to F prime, we flip them and change the sign of Y, right? So -1, 2, right? Flip them, change the sign of Y. To get to G, what would that be? -1, 7. Somebody else now answer. What would H prime be?
3 and negatives, or not, just 3 and 6, right?
3 and 6, correct. Somebody else answer. What would J prime be? 3, 1. And then we're supposed to graph it. How do we do that?
What do you mean?
It is an easy answer. However, sometimes I have found in high school, when you're asked to graph a point, after graphing a bunch of crazy stuff, your brain oozes out your ears. And so got to make sure, you just stick the dots and connect them, right? That's what we're talking about. That is what we mean. That's not possible. This is not some weird sci-fi show.
I guess not biologically, but mentally. Metaphorically, yes. That's a better description.
Maybe that's why you struggle with roast so much.
Yeah, but
All right, F is at 2, 1. F. And G is at 7, 1. 3, 4, 5, 6, 7. G. And H is at 6, -3. 1, 2, 3, 4, 5, 6. H is right there. And finally, J is at 1, -3. Now, no?
No, because it's 2, 1.
This one's just kind of a little lower. I drew it funky. So, without drawing the other one, let's pause a second. I mean, you may have already done it because y'all are crazy people. And I want you to think with your head. I know I'm like contradicting myself all over the place. But I do want you to continue to use your brain. That's a good thing to do. You're not going to make your dumb joke again?
Case in point.
You know what would be really funny? It's not funny. What would be really funny is if that was you making the joke again. Because see, that would be clever. That would be quite clever.
I wasn't even paying attention to it.
I know. That's why it wasn't clever, but it would have been. It would have been. It's kind of like the dumb dad joke where Dad, you're going deaf. And then Dad's response, huh? It's basically the version of that, but it would have been more clever than the dad joke, but it was not clever. Anyway, if I rotate this 90 degrees, where is it gonna go? It's gonna go here, right? If I rotate this 180 degrees, where is it gonna go?
Opposite.
It's gonna go right over here, right? If I rotate this 270 degrees, where are we about to expect to graph something? Right over there, right? All right, let's do our points and see what happens. -1, 2 is f prime. One, 2 is f prime. So it took this and it rotated it around over there. Okay. G prime is at -1, 7. 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. And then H prime is at 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. 3 and 1, which is J prime. Now, let's talk about it. Because something did and didn't happen.
Neither do we.
That's okay, because
I think I've been watching too much TikTok.
that's definitely true, because pretty much, yeah, that's exactly what I was gonna say. Any amount is probably too much. There, I would be hard, I mean, this is true of pretty much all social media in general, but I would be hard pressed to find anything good about any of it. Any positive value. Because it doesn't really add connection to our lives. It subtracts it, arguably. But so, let's talk about what happened. So, didn't I say 270 degrees or did I say 90 degrees?
At the start you said 90 and at the end you said 270.
Oh, okay. Well, that's why we ended up 90 degrees instead of 270 degrees. Well, that makes sense. Yeah, because that's what we did. We rotated it 90 degrees. Great, it's beautiful. Okay, sign some homework. We'll kick you out of here. You have 2 sets of homework. You're gonna be fine. Start it today, or don't, whatever. I can only lead you horses to water. I cannot force you to drink.
You can push us in the water.
I could if my intention was to drown you. Page 635 and 636. Numbers. Actually, no, scratch that. How about just this? 14 through 18. Evens. And then we're also, going to do page 644. Numbers. (14 through 18 evens). Goodbye, kids. Go away. Find somebody that loves you. That's a great theme song about that.